Hello everyone, welcome back to this video series on clinical SAS SDTM programming. In this video, we will see how to program the SDTM.HO domain. So we will first take a look at the CRF form that contributes to the HO domain. So in this CRF form, we have four questions which says, let us take a look at the name of the form first. It says hospitalizations, and then this form has four questions: the date admitted, date discharged, reason for hospitalization, and the hospital unit to which the subject has been assigned or admitted to. So the names of the raw variables which are used to store the information of each of these variables are annotated here. So we generally call these as database annotations. So we will get a raw data set for each form collected. So in that we need to know where each question is getting mapped to or where each question is captured. So the names of the raw variables are HOSTDAT for date admitted, HOENDAT for date discharged, HOREAS for reason for hospitalization, HO unit for the unit in which the patient got admitted to. And then we have our responses. Now, ultimately, the information on this form needs to be mapped to a particular SDTM domain. So, in this case, the domain is HO, which is healthcare encounters. Now, let us see the SDTM variables to which this information gets mapped to. So, we'll first see the date admitted. So, the raw variable name is HOSTDAT. So, and now we are trying to look at the SDTM variable to which this information gets mapped to. So the SDTM standard datetime variables have a suffix of DTC. As this is hospitalization domain, we have this two-letter prefix of HO, and ST stands for start. So hospitalization start date in character format. And then now we will see the variable to which the date discharge gets mapped to. So it is HO, EN, DTC. And then we have our reason for hospitalization. So let us take a look at the SDTM variable to which this gets mapped to. So there is no standard variable in SDTM.HO domain which is meant for capturing this reason for hospitalization. So what is being done here is this information is put into the sub-HO domain. So and the QNAM that is being used is HOREAS. So this information is going to our sub-HO dataset. And then we have hospitalization unit to which the patient got admitted to. So let us see the SDTM variable name for it. So this is going to the variable called HO term in our parent HO domain. So now we have seen the SDTM variables to which each of these raw variables or the information or the questions collected is getting mapped to. Now let us take a look at the input data that we will get out of this form. So here we have our HOSP dataset. This dataset has all the information collected from the form hospitalization. So we had four questions: HOSTDAT, HOENDAT, HOREAS, and HO unit. So as each form will be collected for each subject at specified intervals, so we'll have other variables which are related or used to identify the subject and study, and other some database related information. So we have those variables: project, subject under this folder name, and the record position in the raw database of each record. So in this we have data for two subjects, 1001 and 2003. So for 1001 there are two hospitalizations, or it says the subject got hospitalized because of an adverse event into emergency room on 20th Jan, and it ended on 20th Jan. And from emergency room, the subject got shifted to general ward on the same day. So the start date for general ward is 20th Jan, and the subject stayed in the general ward till 23rd Jan. And then we have our next hospitalization, which is for subject 2003, and this hospitalization began on 10th Feb 2010, and we do not have an end date collected. So now let us move to the program or specification to create this SDTM.HO domain. So what we will learn from this specification is two things. We can either, if we are programming an SDTM domain, we need to understand the specification, or if we are creating the specification, we need to know how to write a specification. So there can be two aspects of this. So now first let us, as the specification is already written, so let's assume that we are using this specification to program our HO domain. So how a programmer has to interpret, or what information they look for, will be known here. So here we are having the names of the SDTM.HO variables that will be used in this SDTM.HO domain. And then we have the general comment, and then we have the specific derivation logics that have to be used for the variables coming from the hospitalization form. So for study ID variable, we are being asked to set the value to myCSG, and then for domain, we are being asked to use a value of HO. And then for USubj ID, we are being asked to use the values from project and subject and concatenate these two values with a hyphen in between. And then HOSEEK, it says the sort the records based on USubj ID, HO term, HOSTDTC, HOENDTC, HOSPID, and assign as 1 on the first record of each subject and increment by 1 for each subsequent record for that subject. So we have seen exclusively in a separate video on how seek variable can be derived in SDTM domain. So the basic requirement would be sort it based on the specified variables and assign the value of 1 on the first record of that subject and increment it by 1 on the further records of that subject. So that is being conveyed here. And then we are being asked to create a variable called HOSPID using the value from record position in HOSP dataset. So it says populate using HOSP dot record position in 3-digit format, padding with leading zeros where applicable. So ultimately, irrespective of the number present in this variable, so we need to have the number presented in a 3-character wide data. So where if the number is only 1, so we are being asked to use 2 additional leading zeros in this number. And then for HO term, the specification says populate it using HOSP.HO unit. So we have to use the value from HOS unit and assign it to HO term. And then there is the derivation for epoch variable. So it says populate epoch using SDTM SC epoch by comparing HOSTDTC with SC STDTC and SCENDTC of each element of the subject, and populate as treatment when a record falls on the boundary of screening and treatment elements, and populate as treatment when the record falls on the boundary of treatment and follow-up. So we know that in the SDTM-SC domain there are no gaps allowed between two elements. So there can be some records which falling on the boundary of two different elements. So we are being given the preference on which value to use when it falls on the boundary. So first between screening and treatment and follow-up. So, and then there is this variable HOSTDTC for which the specification says populate using HOSP.HOSTDAT in ISO 8601 format. The collected date may not be in ISO 8601 format, so we are being asked to convert the collected date into ISO 8601 format and use or present it in HOSTDTC. And then next we have our HOENDTC, and it says populate using HOSP.HOENDAT in ISO 8601 format. And then we have two derived variables which are HOSTDY and HOENDY. These are the study day of start of encounter and study day of end of healthcare encounter. So the derivation says if SDTM HOSTDT is on or after the reference start date, so subtract the RFSTDTC from HOSTDTC and add 1 to that difference. Else if before reference start date, then assign us just the difference between HOSTDTC and SDTM-DM RFSTDTC. So similarly for HOENDY. And then we have our variable called HOENRTPT, which says end relative to reference time point. So it says populate as ongoing when hosp.hoendt is null. And in this variable called hoentpt, so we are asked to populate as end of study when SDTM.HO hoenrtpt is ongoing. So when the end date is missing, we are asked to populate it as ongoing. So we need to tell like at what point in time we are calling this as ongoing. So we specify that time point in this variable called HOENTPT, which is end reference time point. So here when the date is missing, we are saying that the event was ongoing at the end of study, because we will continually ask that question for each hospitalization whether the hospitalization has ended or not at each subsequent visits. And then we have this variable HORES, as this first column is indicating whether a variable is getting mapped to the supplementary domain or not. So we have it as Y. So it says HORES. So reason for healthcare counter, as we do not have any standard variable in HO domain for which this gets mapped to, we are mapping it to a QNAM called HORES in sub HO, and we need to populate it with the same named variable value from HOSP dataset. Now we have seen the specification for HO domain. Let us now move on to the program and see how to implement this. So we have our SDTM programming available here. So the first section says create variables which are directly based on raw data. The raw data which is used as input for this domain is HOSP dataset. So here we are using that HOSP dataset and creating a dataset called HO01. In this dataset we are creating all the variables which have to be manually assigned or which are directly based on the raw data. So for study ID, we were asked to manually populate it with the value of my CSG. So I am populating it with that. And then for domain, we were asked to use the two-letter prefix HO, and we have assigned it to the domain variable. And then we were asked to concatenate study ID and subject. So for creating our useUpJD variable. So we are concatenating study ID and subject with a hyphen in between. And then for HOSP ID, we were asked to populate it with a 3-character wide string wherever and use leading zeros when the number is less than 3 characters. So we are using this Z3 format to convert our record position and store it in a variable called HOSP ID. And then we were asked to create HOST DTC using HOST DAT. So when HOST DAT is not missing, we are converting the value from HOST DAT into ISO 8601 format, wherein the 4-digit year, 2-digit month and 2-digit day would be there. So the date component of ISO 8601 is equivalent to the SAS format of YYMMDD 10 dot. When we only have date collected, we can make use of YYMMDD 10 dot to convert those into ISO 8601 representation. So similarly, HOE and DTC is also being converted by using YYMMDD 10 dot format. So before that, what we are doing here is, so in the input data, the dates are collected in this date 11 format. So they are in character format. So what we are doing here is we are first converting them into numeric format using date 11 in format, and then converting that back into character but into ISO 8601 format or YYMMDD 10 dot format. So and then we were asked to populate HO term variable with the value from HO unit variable. So we are simply assigning that value to HO term. And then for HOENRTPT and HOENTPT, we were asked to check whether HOENDT is null or not. So here HOENDT, when we are checking for whether HOENDT ENDAT is present or not, and then if it is missing, we are populating ENRTPT as ongoing and ENTPT as end of study. So this means the event or the hospitalization was ongoing at the end of the study. And then we are creating here the QNAMs or the supplementary domain related variables. So here HORES was being asked to populate it with the value with the same named variable from the raw data set HORES. So we are just assigning it here again to the same variable. So there will be no change in the input variable. So I have used this approach of still naming it because so that I do not miss uh, any QNAMs to be mapped. And then, so here in this first step, we have created variables which are directly based on raw data or which are simply being asked to assign some explicit text to the variables. And in the next step, what we are doing here is calculating study days. So we know that in order to calculate the study days, we need to fetch the RFSTDTC from DM dataset into our hospitalization dataset so that we can compare our reference start date to the date of interest. So there are two dates of interest here, HOSTDTC and HOENDTC. So we also know that the date variables in SDTM are character format, but in order to get the difference between two dates, so we need to have the date variables available in numeric format. So all the three date variables, which are RFSTDTC, HOSTDTC and HOENDTC, are converted to numeric format using input function and YYMMDD10.in format. So the numeric versions are named with a naming convention without the C at the end. So we can use any name, but if you are following one particular standard, you can choose this way. You can just remove the C at the end and use populate that variable. Say for example, if you are creating numeric version of RFSTDTC, so create it with the name of RFSTDT. And similarly for HOSTDTC, if you are creating a numeric version date for that, create it with HOSTDT. So if you follow one convention, your programming will look more neat and clean. So we have created three numeric versions of these three input variables. And after that, what we are doing here is we are checking whether both of them has a value populated. So we are using nmiss function here on these two variables. So what nmiss function does is it returns the number of variables with missing values. So here we have passed two variables. So it will check how many number of variables have missing values on that particular record, and it would return the value of the number of variables which has a missing value. So for this difference to take place, so we should not have any of the two variables with missing values, which means the number of missing values in these two variables have to be 0 for this calculation to take place. So we are checking for the presence of a value in these two variables and then adding this condition. So here we are getting the difference of HOSTDT and RFSTDT, and then we are using this condition called HOSTDT greater than or is equal to RFSTDT. So in SAS, any logical expression that we use gets evaluated to true or false. If it becomes true, the value returned would be 1, and if it gets evaluated as false, the value returned would be 0. So if we check in the specification, so we were asked to add a value of 1 to the difference between HOSTDT and RFSTDT when HOSTDT is greater than or is equal to RFSTDT. Otherwise, there is no need of adding that plus 1, which means it is equivalent to adding that plus 0. So what happens on a particular record if HOSTDT is greater than or equal to RFSTDTC? So on that record, when the condition becomes true, it would get resolved to 1. Otherwise, the value gets resolved to 0. So technically, this condition is being used as to evaluate as 1 or 0 and add the difference to the difference between HOSTDT and RFSTDT. So this is a short form representation of creating our study day variables. Otherwise, we can use an if then else statement, and if HOSTDT greater than RFSTDT, then take the difference and add plus 1. Otherwise, we can just take the difference of HOSTDT minus RFSTDT without adding any number to it. So we have now calculated the or derived HOSTDY and HOENDY in this step. And then we are creating our epoch variable. So we have seen an exclusive video on how epoch variable has to be derived. So what we do in short is we check where exactly the HOSTDT is falling in between all the start and end dates of all the epochs, and then we will assign the epoch value based on that. For that, what we do is we get the start dates for each of the epoch, and then we also get the end date of each of the epoch as variables, and then we merge the start dates and end dates of each of the epochs into a single record, and then we get the start and end dates of each of the epochs into our hospitalization dataset so that we can compare our HOSTDAT with each of the epoch start and end dates. And after that, we check where our date of interest, which is HOSTDTC, is falling in between the start and end of each of the elements or the epoch start and end dates. And then we assign the epoch value based on that. And then we are creating our HOSEEK variable. This should have been HOSEEK, not RPSEEK. So we are creating our RPSEEK. So in RPSEEK, what we were asked to do is we were asked to sort the variables based on a pre-specified list of variables. So we are sorting the records based on that set of variables, and then on the earliest record of each subject, we are assigning a value of 1 to HOSEEK variable. On the other records, we are incrementing it by 1 by making use of sum statement here. So you might have seen in some of the earlier videos that we might have used the retain concept, but here we are making use of sum statement. So sum statement inherently has that option of retaining the value from previous observation to current observation. So we are making use of that instead of using an explicit retain statement here. And then at the end, we need to keep only the required variables which are there in this. So here I have not covered explicitly on how to create supplementary domain, but you can watch my other video on how to create supplementary data sets. So all we need to do is bring this HORES variable into a separate data set called sub-HO based on the processing described in that video. So now we have seen how this entire dataset programming works. So let us now quickly take a look at the intermediate datasets that get created. So we have our original input dataset HOSP. So these had the variables HOSTDT, ENDT, and HORES. And in the first hospitalization, in the first step, what we have done is created some variables which are directly based on this one. So as part of that, we have created study ID, domain, HOSP ID, HOSTDTC, ENDTC, ENRTPT, and ENTPT. And after that, we have created our study day variables by fetching our RFSTDTC into hospitalization related data set. So we have fetched the character date, we have converted it into numeric date. Same process has been applied to the start date and end date of hospitalization, and then we created HOSTDY and HOENDY, and then we processed our epoch start and epoch end date. So epoch start, we have created a separate variable. So let's see the SC dataset. So we have one record per element or per epoch in this case. So for each subject. So we are transforming this dataset to have one record per subject with start date of each epoch as a separate variable. So here now we have created one record for each subject with start date of screening and start date of treatment and start date of follow-up. So in this dataset we'll have one record per subject with the start dates of each of the epochs into which the subject has entered as a variable. And similar processing is being done for end date of each epoch for each of the subjects. And then we merge the start dates and end dates into a single dataset so that we can bring this dataset into our hospitalization dataset and make the comparison with our hospitalization date with the start and end dates of each of the epochs. So in HO03 is the just sorted data set. In HO04 we have done that epoch variable creation. So we have fetched our start and end dates of each of the epoch into our hospitalization dataset, and then we compared our hospitalization start date with each of these dates, and then we assigned the epoch based on, I think we have done this in the next dataset HO05. So and we have assigned the epoch value based on where the hospitalization start date falls. So let us quickly examine how this epoch values are populated for these three values. So if we take a look at the hospitalization start date on the first record, it is on 20th Jan. So we will examine the start where exactly in between in which of the elements start or the epoch start and end dates this particular start date falls in. So screening started on 3rd Jan and it ended on 15th Jan, and then treatment started on 15th Jan and then ended on 25th Jan. So 20th Jan is clearly falling it between the treatment start and end date. So we need to populate the epoch as treatment here. And then now let us take a look at the second record. Again, this is on the same day the subject got moved to general ward from emergency room. So the epoch will still be treatment here because the date is same and it falls in between the start and end dates of the treatment epoch. And then for the second subject, the start date is on 10th Feb. Now let us take a look at the dates of each epoch for this subject. So screening started on 27th Jan and then treatment started on 3rd Feb and the subject did not enter into follow-up yet, and then treatment ended on 10th Feb itself. So we were asked to populate it as treatment when it is falling on the when it is, let me quickly go back to the specification and then see. Actually, this record is not falling on the boundary of anything. It is directly as the subject did not enter into follow-up. Did the subject enter into follow-up? Do we? Let's quickly go to the right and check that. So the subject has the last date for treatment is present, but the subject did not enter into follow-up yet. So the hospitalization start date is on the same date as treatment end, so we still should need to populate it as treatment. So we have it as treatment here. So and then in the next step what we have done here is created our seek variable. So we have sorted our observations based on the data variables provided, and then so we have assigned the value on the first record of that subject and we were asked to increment it by 1 on the subsequent records. So as this is the second record, we have assigned the value as 1 on the first record. We have incremented it by 1 on the subsequent record. And if there was a third record, we would have added 1 to this, so it would have become 3. So within this subject. So as this is the first record of the second subject, which was 2003, I think. So we have assigned it as a value of 1. So this is how we can program SDTM.HO domain. So we have seen how the CRF form is designed to collect some information. We have seen how the variables get mapped to into SDTM.HO domain, and then we have seen how to see or write or interpret the SDTM specification. We have seen the overview of programming, and we have examined the intermediate data set that is getting created out of the input data, out of the program. So thank you for watching and keep learning.